For this problem, we're going to use our transformation techniques to graph some functions. We're going to graph each function using the techniques of shifting, compressing or stretching, and reflections. We're going to start with the graph of the basic function, then we're going to show all stages. We have two parts. The first part, we want to graph h of x equals -2 times the quantity x plus 1 cubed, and then plus 3. And in the second part, we want to graph g of x equals the absolute value of x plus 4 plus 2. We're going to begin with part A. In part A, our base function will be the cube function, y equals x cubed. So we're going to go ahead and graph by hand this basic function. I'm just going to plot a couple of points. We want to notice that our scale is different for the y-axis and the x-axis. Here we're using a scale of 1/2, and here we're using a scale of 2. It's going to be important when we plot our points. We're going to start with x equal to 0. If x equals 0, then y equals 0. And so we have this point, 0, 0. If we let x equal 1, 1 cubed is 1. Remember, our scale is 1/2. So when x is 1, y is also 1. So we have the point 1, 1. Go the other way and we'll let x equal -1. -1 cubed is -1. So go over to -1, down 1. And so we have the point -1, -1. Now, knowing that this x cubed function has the basic shape of that function, the left side will go down, the right side will go up. So we'll get a rough graph. Looks something like this. And so there's the graph of our base function, x cubed. The first thing that we want to do from our base function is we're going to shift the graph to the left 1 unit. That's going to give us the graph of y equals x plus 1 quantity cubed. We're trying to build to our given function. Here in this lighter shaded graph, this is our original function, x cubed. And we're going to shift that 1 unit to the left. If we think of one of the points we used on our original graph, we had 0, 0. If we shift that 1 unit to the left, we'll get the point -1, 0. And so we've got our 3 points plotted after the transformation. So here's the graph of y equals x plus 1 quantity cubed. The next thing we're going to do is reflect our graph around the x-axis. That's going to give us the graph of y equals -x plus 1 quantity cubed. Again, this shaded graph right here represents our last graph that we had over here. And the reflection then, we can see that if we use the point -2, -1 on this graph, and we reflect it around the x-axis, we'll get the point -2, +1. Our next step is to multiply by 2. That's going to be a vertical stretch by a factor of 2. And that will give us the graph of y equals -2 times x plus 1 quantity cubed. And the shaded graph represents our previous graph. And we can see what happens after we do the transformation. This vertical stretch, basically grab the ends of the graph and pull it up, so we get this kind of stretching here. The last thing we need to do is shift our graph up 3 units. That will give us the graph of y equals -2 times x plus 1 quantity cubed plus 3. And the shaded graph is our graph from over here. If we pick one of these points, say -2, 2, if we shift that up 3 units, we're adding 3 to the y coordinate, so we'll get the point -2, 5. So you can see we're taking this lightly shaded graph and just shifting it up 3 units. And this is our final graph. This is the graph of h of x. Now let's graph the function in part B. In part B, our base function is going to be y equals the absolute value of x. So we're going to graph that base function here. Notice that we have the same scale on both the x and y axes. Our scale is going to be 2 units. To graph the absolute value of x, we're going to plot a couple of points. Start off by letting x equal 0. If x is equal to 0, y is equal to 0, until we have the point 0, 0. If we let x equal 2, the absolute value of 2 is also 2, so we get the point 2, 2. If we let x equal -2, the absolute value of negative 2 is positive 2, and so we get the point negative 2, 2. Connect our points, get our graph, and here we have the graph of our base function, the absolute value of x. The first thing we'd like to do with our base function is to shift that graph 4 units to the left. That will give us the graph of y equals the absolute value of x plus 4. This lightly shaded graph represents our base function, and then this graph represents our base function shifted 4 units to the left. If we look at one of our points, for instance the origin, on our base graph we had the point 0, 0. If we move 4 units to the left, we get the point negative 4, 0. The last thing we need to do is to shift this graph up 2 units. That will give us the graph of the absolute value of x plus 4 plus 2. So we're going to take this graph and shift it up 2 units. If we pick a point, say negative 6, 2, go up 2 units, that will correspond to the point negative 6, 4. We've added 2 units to the y coordinate. This is our final graph, so this is the graph of g of x.